I have question 15. It states, a thin glass rod is submerged in oil. What is the critical angle for light traveling inside the rod? Okay, so let's find out our known variables and our unknown variables. So we know the index of refraction for oil and glass. So oil is 1.46. Glass is 1.5, roughly. We also know that critical angle is when the transmitted angle equals 90 degrees. So basically you can put the angle, or theta, of the transmitted equals 90 degrees. What we don't know is the angle of incident yet. So that's an unknown. That's what we're trying to find. So the equation we're going to use to solve this is, I can't remember what it's called exactly. I think it's Snell's law. Basically says the index of refraction of the incident times the sine of the angle of the incident equals the index of refraction, the transmitted, times the sine of the angle of the transmitted. So we know three of those things, except for the one. So we're going to find the one, so we need to put it on one side of the equation by itself. So if we rewrite that, we have the angle of the incident equals the arc sine, and this is just algebra that we're doing here, of all this side of the equation, the index of refraction of the transmitted times the sine, the angle of the transmitted, all over, not all, but just this inside the parentheses is over the index of refraction of the incident. Here, let's make that a little clearer. There we go. There we go. And then we just plug in our numbers. This stays the same. Okay, so the transmitted will be what it's going into. The light starts in the glass, so that's incident. Transmitted will be oil. And so therefore, that is going to be the 90 degrees. And then that will be the glass. And if you solve for that, you get 76.7 degrees. Which basically says anything shallower than that will not leave the glass rod. The light will be refracted and stays inside the rod. Therefore, you can't see it.